Good morning, dear students. This is Dr. KSNV Prasad, Assistant Professor, Department of Chemical Engineering, BVRIT, Narsapur. Today in this video, we will be discussing the course Chemical Process Safety, and the topic is Toxicity and Radiation. So before going into the topic, let us go through the different classes of hazardous elements. The hazardous elements are classified into 9 different classes. Class 1 explosives, Class 2 gases, Class 3 flammable liquid and combustible liquid, Class 4 flammable solid, spontaneously combustible and dangerous when wet, Class 5 oxidizer and organic peroxide, Class 6 poison and poison inhalation hazard, Class 7 radioactive, Class 8 corrosive, Class 9 miscellaneous. So thus the hazardous materials are classified into 9 different classes. Coming to the case of toxicity, toxicology refers to the study of adverse effects of chemicals on human health, whereas toxicity is a measure of degree of harmful nature of a substance. A chemical is said to be a poison if it causes some degree of metabolic dysfunction in organisms. Toxicity can be defined as the relative ability of a substance to cause adverse effects in living organisms. Example, release of methyl isocyanate at the Union Carbide pesticides plant at Bhopal killed thousands of people, which additionally caused or causing permanent damage to the human life. The routes of exposure of toxic elements are, there are 4 different routes. First one is inhalation, second one is absorption by skin or eye, third one is ingestion, and fourth one is injection. Coming to the case of the first subsection, inhalation, for most chemicals in the form of vapors, gases, mists, or particulates, inhalation is the major route of entry. Once inhaled, chemicals are either exhaled or deposited in the respiratory tract. If deposited, damage can occur through direct contact with the tissue, or the chemical may diffuse into the blood through the lung-blood interface. Upon contact with the tissue in the upper respiratory tract or lungs, chemicals may cause health effects ranging from simple irritation to several tissue destructions. Substances absorbed into the blood are circulated and distributed to the organs that have an affinity for that particular chemical. Health effects can then occur in the organs which are sensitive to the toxicant. Skin or eye absorption. Skin contact can cause effects that are relatively innocuous, such as redness or mild dermatitis. More severe effects include destruction of skin tissue or other conditions. Many chemicals can also cross the skin barrier and be absorbed into the blood system. Once absorbed, they may produce systematic damage to the internal organs. The eyes are particularly sensitive to the chemicals. Even a short exposure can cause severe effects to the eyes, or the substance can be absorbed through the eyes and be transported to other parts of the body, causing harmful effects. Ingestion. Chemicals that inadvertently get into the mouth and are swallowed do not generally harm the gastrointestinal tract itself unless they are irritating or corrosive. Chemicals that are insoluble in the fluids of the gastrointestinal tract are generally excreted. Others that are soluble are absorbed through the lining of the gastrointestinal tract. They are then transported by the blood to the internal organs, where they can cause damage. Finally, injection. The substances may enter the body if the skin is penetrated or punctured by contaminated objects. Effects can then occur as the substance is circulated into the blood and deposited in the target organs. Some common toxic substances are PCBs, polychlorinated biphenyls, cause a wide variety of health effects, often at very low exposure levels. Some have properties such as dioxins, one of the most toxic man-made compounds in the world. Dioxins are a group of chlorinated organic chemicals with similar chemical structures. Some PCBs act like hormones and others are nerve poisons. PCBs alter major systems in the body immune and therefore affect a wide variety of body organs and functions. Human exposure to dioxins can cause slow development as well as reproductive and immune disinfection. It is also strongly indicated that dioxins promote cancer by making its proliferation easier. Second one is lead. Overexposure to lead is one of the most common overexposures found in industries and is a leading cause of workplace illness. Lead accumulates in blood, bones, kidneys, liver, brain, and other parts of the human body. And inorganic lead compounds are well known to cause significant health effects following long-term exposure. If a significant amount of lead has accumulated in the body, symptoms of long-term toxicity may develop after what may seem to be a short-term acute exposure. Mercury. When elemental mercury is released into the environment, either from the atmosphere or from the industrial or other human sources, bacteria in rivers and lakes may convert the metal into organic form called methyl mercury. This form of metal is assimilated by large organisms when they consume the bacteria and mercury begins its journey up the food chain. Symptoms of acute mercury poisoning include numbness or tingling of the fingers, toes and mouth, headache, memory or hearing loss, visual or speech disorders, and lack of coordination. In most cases, it can lead to coma and death. Pesticides. Hazard depends on the toxicity of the pesticide and the amount of exposure to it. By understanding the difference in toxicity levels of pesticides, a user can minimize the potential hazard by selecting the pesticide with the lowest toxicity that will control the pest. For example, organophosphates may cause acute or chronic poisoning. Suspected chronic effects from exposure to certain pesticides include birth defects, toxicity to a fetus, production of benign or malignant tumors, genetic changes, blood disorders, nerve disorders, endocrine disruption, and reproduction effects. The symptoms of pesticide poisoning can range from a mild skin irritation to coma or even death. Systematic effects often include nausea, vomiting, fatigue, headache, and intestinal disorders. Solvents and petroleum products. These substances are serious toxins and usually cause symptoms after the fumes have been accidentally inhaled. The symptoms are drowsiness, dizziness, nausea, and occasionally vomiting. If severe exposure occurs, the patient may become unconscious. If they are swallowed, they usually produce the same symptoms, but nausea and vomiting are worse. They may also enter the human body through skin contact. Many are carcinogens and the central nervous system is poison. They should be avoided. Nickel carbonyl. It is one of the most poisonous inorganic compounds. Both nickel and carbon monoxide, both being themselves poisonous, and to the poisonous effects of nickel carbonyl. Nickel in catalysts is the source of nickel carbonyl formation in reactors and other process equipment. Many hazardous incidents took place in refineries, ammonia plants, hydrogenation units for oils and fats. Plant shutdown conditions are most favorable for nickel carbonyl formation. The measures, coming to the case of measures of toxicity, LD50 is one of the important measures. The amount of a chemical that produces death in 50% of a population of test animals to which it is administered by any of a variety of methods and expressed as milligrams of a substance per kg of the body weight of the test animal. The period of exposure is 4 hours and the observation period is 14 days. The lower the LD50 dose, the more toxic the substance. For example, a pesticide with a LD50 value of 10 mg per kg is 10 times more toxic than a pesticide with an LD50 of 100 mg per kg. So that means as the LD50 value decreases, its toxicity increases. Next measure is LC50. The concentration of a chemical in an environment which produces death in 50% of an exposed population of test animals in a specified time frame, expressed as milligrams of substance per liter of air or water. Next one is LD low, lowest dose reported to have caused death in animals or humans. Next one is TC low, lowest concentration reported to have produced any toxic effect. Next one is threshold limit value. TLV is a level to which it is believed a worker can be exposed of a chemical substance day after day for a working lifetime without adverse health effects. TLV for a chemical substance is defined as the concentration in air typically for inhalation or skin exposure. Its units are in ppm of air for gases and in milligrams per cubic meter for particulates such as dust, smoke and mist. TLVs are recommended values by American Conference of Governmental Industrial Hygienists. Types of TLVs. Time weighted average, TLV, TWA, average exposure on the basis of 8 hour per day, 40 hour per week work schedule. Short term work limit, TLV, STEL. Spot exposure for a duration of 15 minutes that cannot be repeated more than 4 times per day. Types of TLVs. Ceiling limit, absolute exposure limit that should not be exceeded by at any time excursion limits. There is a general excursion limit recommended that applies those TLV TWAs that do not have TLV STELs. Excursions in worker exposure levels may exceed 3 times the TLV TWA for not more than a total of 30-minute duration a workday, and under no circumstance should they exceed 5 times the TLV TWA provided that the TLV TWA is not exceeded. Permissible exposure limits. These are regulatory limits on the amount or concentration of a substance in air and are enforceable. Biological limit values. BLV is a reference value presented as the concentration in the appropriate biological medium of its metabolite or indicator of effect. BLVs refer to the limiting values of substances to which a worker may be exposed without any health hazard. BLVs are reference values for the evaluation of potential health risks in the practice of industrial hygiene. BLVs are representative of the levels of determinants which are observed in workers exposed to the respective chemical exclusively by inhalation. Immediate dangers exposed to a life or health ideal height. The maximum level to which a healthy individual can be exposed to a chemical for 30 minutes and escape without suffering irreversible health effects or impairing symptoms. The term IDLH is defined by Occupational Safety and Health Administration of US as an atmosphere that poses an immediate threat to the life, which cause irreversible adverse health effects or would impair ability of an individual to escape from a dangerous atmosphere. Next, coming to the case of biohazards. Biohazards are infectious agents or dangerous biological materials that present a risk or potential risk to human or animal health or the environment. The risk can be direct through infection or indirect through damage to the environment. Pathogens are germs that can cause disease. Simply stated, microbes, biohazards, and pathogens are germs. Common types of germs are bacteria, viruses, and fungi. There are a variety of germs in buildings that can pose a potential health risk. They include viruses like HIV-1, hepatitis A, B, and C, herpes simplex, and influenza. Bacteria such as Staphylococcus, Pseudomonas, Salmonella, E. coli, stubborn antibiotic strains such as vancomycin-resistant Enterococcus and methicillin-resistant Staphylococcus aureus, and toxic mold strains such as Stachybotrys. Coming to the case of radiation, there are a number of units to measure radiation dose and exposure. First one is RAD or radiation absorbed dose, the amount of radiant energy absorbed in a certain amount of tissue. Next one is Gray, a unit of absorbed radiation equal to the dose of 1 joule of energy absorbed per kilogram of matter, or 100 rad. The unit is named for the British physician L. Harold Gray, an authority on the use of radiation in the treatment of cancer. Milligray, a unit of absorbed radiation equal to 1,000th of a gray. Rem or Roentgen, equivalent man, a unit of measurement that takes into account different biological responses to different kinds of radiation. The radiation quantity measured by the REM is called equivalent dose. Millirem, 1,000th of a REM, the unit for measuring equivalent dose. Roentgen, the international unit of exposure dose for X-rays or gamma rays. Roentgens are named after Professor William Conrad Roentgen, a man who discovered X-rays in 1895. Sievert, the unit for measuring ionizing radiation effective dose, which accounts for relative sensitivities of different tissues and organs exposed to radiation. The radiation quantity measured by sievert is called effective dose. Millisievert, 1,000th of a sievert, the unit for measuring effective dose. Exposure to 50 to 100 millisievert changes in blood chemistry. 500 nausea within hours, 700 vomiting, 750 hair loss within 2 to 3 weeks, 900 diarrhea, 1000 hemorrhage, 4000 possible death within 2 months if no treatment is taken, 10,000 destruction of intestinal lining, internal bleeding and death within 1 to 2 weeks, 20,000 damage to the central nervous system and loss of consciousness within minutes and death within hours or days. So these are the exposure limits and the effects. If radiation is 0 to 100 Roentgen, no serious effects. 100 to 200 nausea and fatigue, 200 to 300 nausea and vomiting, 300 to 600 nausea and vomiting for the first few hours, loss of hair, loss of appetite, discomfort, etc. And greater than 600, all the above symptoms at shorter period of exposure, possible death up to 100% of exposed individual. The effects of being exposed to larger doses of radiation at one time vary with the dose. Here are some examples. 10 cigarette, risk of death within days or weeks. 1 cigarette, risk of cancer later in life. 100 milli cigarette, risk of cancer later in life. 50 milli cigarette, TLV for annual dose for radiation workers in any 1 year. 20 milli cigarette, TLV for annual average dose averaged over 5 years. The ionizing radiation comprises of X-rays and gamma rays, whereas the non-ionizing radiation comprises of radio waves, microwaves, infrared radiation, visible light and ultraviolet radiation. So these non-ionizing radiations consist of lower energy, whereas higher energy the ionizing radiation comprises of higher energy. Radiation is the energy that is transmitted in the form of waves or particles. Non-ionizing radiation is the form of radiation with less energy than ionizing radiation. Unlike ionizing radiation, non-ionizing radiation does not remove electrons from the atoms or molecules of materials that include air, water and living tissue. Examples of this kind of radiation are radio waves, visible light and microwaves. Ionizing radiation is a form of energy that acts by removing electrons from the atoms and molecules of materials that include air, water and living tissue. Ionizing radiation can travel unseen and pass through these materials. Ultrasound is the safest known medical imaging modality and can be used by nearly every patient with little or no risk, because ultrasound consists of less radiation when compared with the remaining procedures. And whereas CT is somewhat more dangerous because the radiation is more. Factors affecting the exposure and risk. Time of exposure and intensity are important factors. Longer exposure periods cause greater damage. Intensity depends on strength of source, distance and existence and nature of shielding. Some radioactive isotopes have high intensity and are more hazardous. Intensity from a point source is inversely proportional to the square of the distance. An alpha particle is a particle that is identical to a helium-4 nucleus. It consists of 2 protons and 2 neutrons and has a positive +2 charge. And beta particle is a high-speed electron. This table presents the differences between alpha rays, beta rays and gamma rays. Alpha rays are helium nuclei consisting of 2 protons and 2 neutrons. Beta rays are electrons, basic elementary particles in all atoms. Gamma rays, they are electromagnetic waves consisting of photons. Charge, positively charged particles, +2e, negatively charged particles, -e, and neutral particles, 0. Ionizing power, 100 times greater than beta rays and 10,000 times greater than gamma rays. Comparatively low, very less ionization power. Penetrating power, low penetrating power for alpha rays, medium penetrating power for beta rays and very high penetrating power for gamma rays. Effect of electric and magnetic field. Deflected by both the fields, but the direction of the deflection is opposite to that of the alpha rays. And coming to the case of gamma rays, they are not at all deflected by both the fields. Speed. For alpha rays, their speed ranges from 1/10 to 1/20 times the speed of light. For beta rays, their speed can go up to 9/10 times the speed of light. And for the case of gamma rays, they travel with the speed of light. So, types of ionizing radiation. X-rays are similar to gamma rays in that they are photons of pure energy. X-rays and gamma rays have the same basic properties but come from different parts of the atom. X-rays are emitted from processes outside the nucleus, but gamma rays originate inside the nucleus. They also are generally lower in energy and therefore less penetrating than gamma rays. X-rays can be produced naturally or by machines using electricity. Literally, thousands of X-ray machines are used daily in medicine. Computerized tomography, commonly known as CT or CAT scan, uses special X-ray equipment to make detailed images of bones and soft tissues in the body. Medical X-rays are the single largest source of man-made radiation exposure. X-rays are also used in industry for inspection and process control. X-rays are produced due to the sudden deceleration of fast-moving electrons when they collide and interact with the target anode. In this process of deceleration, more than 99% of the electron energy is converted into heat and less than 1% of the energy is converted into X-rays. Differences between X-rays and gamma rays are: the key difference is the source. X-rays are emitted by the electrons outside the nucleus and gamma rays are emitted by the excited nucleus itself. Gamma rays have the highest energy in the EMR spectrum and their waves have the shortest wavelength. Gamma rays are a lot more dangerous and hazardous to human health than X-rays. With this, we come to the end of the topic. Have a good day.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.